Hi everyone, it's Vath with AUB. Frame 17 of 23 for the preparation of IBA direct test. Let's start with a warm-up question. What is the value of 1 plus 7 over 5 overall divided by 1 minus 5 over 7? Fraction, another fraction, a bunch of fractions. It is a cumbersome for a student or a nightmare of a beginner. For arithmetic calculation, it's really very easy. Instead of upon, introduce divide as 1 plus 7 over 5. Instead of overall division, introduce symbol of divide 1 minus 5 over 7. Take a relief of sigh. You have done something good, something good. Now the situation is in your control. Just take LCM. There is one. Take LCM. Multiply the denominators. 1 times 5 in that direction. 1 5 the 5 plus 1 7 the 7 divided by 1 7 the 7. Taking LCM. Sorry, 1 7 the 7. 1 into 7 multiply denominators. 1 7 the 7. 1 5 the 5. 7 minus 5. 5 plus 7 12. 1 5 the 5 divided by 7 minus 5 2 over 7. To calculate this thing, divide into multiplication, and whatever is present after division, take its reciprocal. So it can be written as 12 over 5 times 7 over 2. 7 over 2. We have converted division into multiplication, and we have reciprocal the term. Reciprocal it, inverted, upside down. We have taken its multiplicative inverse. Applying table of 2. 6 times. So I have 6 times 7 over 5. 6 times 7 over 5. It will become 42 divided by 5. 42 divided by 5. 42 that is not the answer. That is the not answer. Maybe it is written in mixed fraction. 42 divided by 5. 8 5 the 40. 8 whole 2 upon 5. Either answer is written in this form or 8 divide 2 upon 5. 2 upon 5. It's smaller, it's greater. Introduce 0.0 here. 4 5 the 20 or 8.4. 8.4. 8 whole 2 upon 5 or 8.4 is our answer in that case. Is our answer in that case. Our warm-up question. Division, another division. Replace main division main division by this symbol divide. It's really very easy. Just cool. Take LCM, take LCM. After finally convert division into multiplication, reciprocal the term after division. After division, whatever the present, take its reciprocal. Applying table of 2, 6 7 the 42 over 5. Answer cannot be written in that form. In quantitative mathematics, might be written in that fashion or in that fashion. Okay. Moving towards question number 2. Elegant question. For how many positive integers? A. It is true that a square is less than or equal to 2a. A square is less than or equal to 2a. Positive integers start from 1, 2, 3, like natural numbers 1, 2, 3, 4, 5, 6. Put 1, 2, 3 and check the inequality. If inequality is valid, keep on taking the numbers 1, 2, 3 and counting them. It's our answer. Let's see and find out how a square less than or equal to a. Where a belongs to natural numbers or a belongs to positive integers. Positive integers. Positive integers. Whatever suits you, go ahead. Put n is equal to 1 and check. 1 square is less than or equal to 2 times 1. 1 is less than or equal to 2. Yes, inequality is valid. Inequality is valid. 1 is less than 2. 1 is less than 2. Inequality is valid. What about a is equal to? Put a is equal to a square less than or equal to 2a. A is 2. 2 square is less than or equal to 2 times 2. 4 is less than or equal to 4. Still it is valid. 4 is equal to 4, less than or equal to, less than or equal to. Second portion of this inequality is valid. 4 is equal to 4. 4 is less than or equal to 4. This inequality is valid. What about 3? Put a is equal to 3. A square is less than or equal to 2. Put a is equal to 3. 3 square is less than or equal to 2 times 3. 9 is less than 6. 9 is less than or equal to 6. This inequality is not valid. This is not valid. So only two numbers, 1 and 2, 1 and 2 satisfy this inequality. 1 and 2 only satisfy this inequality. So there are only two numbers that satisfy the given equality. A square less than or equal to 2a, where a belongs to natural numbers or positive integers. As mentioned, we have followed the instruction of the question. One verified the inequality as well as 2. 3 doesn't. What about 4, 5? We one can check. They also not satisfying this. 4 square 16. 16 is less than or equal to that. No, it is not valid. Only for two numbers it is valid. For integers. For positive integers 1 and 2, this inequality is valid. It is also valid for 0, but we are restricted to take positive integers. It is valid for 0. 0 square is less than or equal to 2a. 0 is less than or equal to 0. It's valid. But we have been restricted to take positive integers. That's why we have confined ourselves to only two integers, 1 and 2. Second, such type of questions are present in IBA Karachi. Just comprehend the situation rather than cramming and apply the concept. As even definition is mentioned, a number is nifty if it is the multiple of 2 or 3. A number is nifty if it is 2 or it is divisible by 2 or 3. If it is a multiple of 2 or 3, multiple or divisible, same thing. Nifty. Multiple of 2 or 3, multiple, it is valid to say divisible by 2 or 3. 2 or 3. Now we have to hunt all the nifty numbers between minus 11 and 11. We have to hunt all the nifty numbers between minus 11 to positive 11 that are multiple of 2 or 3, or it is equivalent to say that it is divisible by 2 or 3. Let's write all the numbers between minus 11 and 11 integers. So minus 10, minus 9, minus 8. Keep on adding 1. Keep on adding 1. Minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take the nifty numbers. Divisible by 2 or 3. Multiple of 2 or 3. It is a multiple of 2. It is a multiple of 3. It is a multiple of 2. It is a multiple of both 2 and 3. It is a multiple of 2. It is a multiple of 2. It is both multiple of 2 as well as 3. Because 0 is valid for all the cases. 2 0 the 0, 3 0 the 0. It is multiple of 2, it is multiple of 3, it's multiple of 2, it's multiple of 2 and 3, it's multiple of 2, it's multiple of 3, it's multiple of 2. Just count the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Might be one number is missing in my, let me count again. Minus 10, 9, 8, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. A single number is missing. Let's see and find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What about there? Minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2. And that is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me count again. 1, 2, 3, 4, 5. This is also divisible by 3. We have missed 3. 3 is a multiple of 3. Minus 3 is a multiple of 3. Minus 3 is a multiple of 3. So there are now 15 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 are the numbers. So there are 15 numbers between minus 11 and 11 that are multiple of 2 or 3 or divisible of 2 or 3. Multiple of 2 or 3, one can say that it is divisible by 2 and 3. Both statements are tantamount. So these are the numbers: minus 10, minus 9, minus 8, minus 6, minus 4, minus 3 that we have missed. Minus 2, 0, 2, 3, 4, 6, sorry, 6, 8, 9 and 10. They are 15. Look, it is a multiple of every number, whether it is 1, 2, 3, 0. 0 is a some magical number. Division by 0 is not allowed. Otherwise, 0 works miracles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 are the numbers between minus 11 and 11 that are multiple of 2 or 3. Multiple of 2 or 3, one can say that divisible by 2 or 3, it's same. A number is nifty if it is multiple of 2 or 3. 2 or 3. Such type of questions are present, especially in IBA Karachi or at good level of exams. They give the definition itself. You have to follow this definition. A number is nifty if it is multiple of 2 or 3. Just hunt the multiple of 2 and 3 between minus 11 and 11. Between means minus 11 and 11 both are excluded. I have written minus 10 to positive 10 and then I have sorted out which one is a multiple of 2 or 3 or both. Okay, 15 is the answer in that case. Good question. Another good question, IQ type question. If m and n are odd integers, then which of the following must be an odd integer? If m and n both are odd integers. Let me erase this first, then explain the question to you. Okay. M and n. M is odd and n is odd. It is given to us. M and n are odd integers. Odd integers. Then which of the following must be an odd? Number 1. M times n. M is odd times odd. Odd times odd, result is always odd. Result is always odd. One can reconcile this fact by taking any odd numbers. Take 3, 5, 3, 5 the 15. Take both same numbers, 3, 3 the 9, 1, 3 the 3. Take any two odd numbers, multiply them, result is always odd. That is the general study. Odd times odd, result is odd. So number 1 is odd. Number 1 is odd. Good. Second one is m over n. Second is m over n. Sometimes if m is divisible by n, then it will give us odd. Then it will give us odd, but not always. Look at this. If I take 5 and 3, it's a fraction. It's a fraction. Take 3 and 7, it's a fraction. If n divides m, the result is odd, but it is not the case always. It is not the case always. Look at this. The division of two odd number is not always an odd integer. Division of two odd integers is not always an odd integer. They are the fraction, rational number. So m over n is not odd, not odd, not odd. Odd means always odd. Sometimes it is odd, sometimes not. So we discard this option. Discard this option. Moving towards third option. Third is m times n plus 1 whole square. Good. We have already decided odd times odd result is odd. So m times n, odd times odd, result is odd. So I can write instead of m times n, odd plus 1 whole square. We are familiar. If we add 1 in any odd integer, the result is even. The result is even. Add 1 into odd, result is even. So I have even square. And we are familiar. Even square means even times even, result is always even. Result is always even. Take any two even integers. 4 to the 8, 4 6 the 24, 0 times 2, 0. Even times even, result is even, result is even. So we are asked to find if m and n are odd, which one is odd? It is sometimes odd, sometimes not. We have discarded this option. This option is always even. We discard this. Only one is true. M times n is odd. M times n is odd. So number one is only true in that case. It is the case m times n is odd if m and n both are odd. Question number 5. Good. Based on exponential. Google type question. Google type, but easy one. How to deal exponents? One is familiar. Let's see and find out. Let's correct this question. If 50 raised 100, 50 raised 100 is equal to k times 100 raised 50. 100 raised 50. 50 raised 100. 50 raised 100 is k times 100 raised 50. That is the case. What is the value of k? Solve for k. So this 100 power 100 raised 50 from multiplication to division, I can write 50 raised 100 divided by 100 raised 50. That is the value of k. That is the value of k. Now we have to simplify the situation. Look, there is in base it is 50, it is 100. It is 50, it is 100. So I can manage from 100 of 50, 2 times 50, 2 times 50. One can write 50 times 50 raised 100 overall. 100 can be written as 2 times 50 raised 50. Numerator is same, 50 raised 100. Instead of 100, I have written 2 times 50 raised 50. By the exponent rule, A, B overall M, it can be written as A raised M times B raised M. By exponent rule, this one can be written as this. So I can distribute 50 to 2 as well as 50. I have 50 raised 100 divided by 2 raised 50 times 50 raised 50. Now look at this. They are in division, both have same base 50. Both have same base 50. Same base 50. So I can subtract lower power from upper because lower power is shorter than is smaller than, sorry, so now 50 raised 50, it is a smaller power in comparison to 50 raised 100. I have said shorter, sorry, smaller. 50 raised 100 minus 50 divided by 2 raised 50. 2 raised 50. What I have done here, 50 raised 100. If I can write this 50 raised 50 in denominator as 50 raised minus 50, bases are same. At the powers 100 minus 50, that I have done here direct. 100 minus 50, what is the result? 50 raised 50 divided by 2 raised 50, 2 raised 50, 2 raised 50. Let me check whether I am in frame or not. Let me erase this. Okay. Finally, we have k is equal 50 raised 50. Let me write again. 2 raised 50. 2 raised 50. Look here. 50 power 50, 2 power 50. Both have same powers. I can write 50 over 2. K is equal to 50 over 2 raised 50. Because both have same powers. By the virtue of this rule, A over B raised M can be written as A raised M divided by B raised M. Instead of this, I can write this. I have done this. Applied a table of 2. 25 times K raised K is equal to 25 raised 50. K is equal to 25 raised 50. K is equal to 25 raised 50. So our option in that case is B, 25 raised 50. 25 raised 50, that is the case. I have switched 100 raised 50 from multiplication to division. There's 50, there's 100. I can manage a 50 from 100. I have written 100 2 times 50, keeping the power intact. By virtue of the exponent rule, I can distribute. There is no middle symbol, positive or negative. I can distribute this power to 2 as well as 50. I have done so. 2 raised 50, 50 raised 50. Now bases are same, bases are same. I have subtracted the smaller power from greater power, bigger power, smaller power from greater power. I have subtracted 50 from 100. 50 raised 100 minus 50, it will become 50 raised 50 divided by 2 raised 50. Look, in that case, both have same power, 50. I have written this step again, 50 raised 50, 2 over 50. Both have same power. By virtue of this law, I have turned overall exponent to 50 over 2 raised 50, overall 50. Like a raised m b divided by b raised m can be written as a divided by b raised m. I have done so here. 50 divided by 2 raised 50. Applying table, 25 raised 50 is my answer. Moving towards a good question, a wonderful question. I say that is the interval, magical interval, where mathematics is upside down. Where mathematics is upside down, that is the interval from 0 to 1, open interval 0 to 1, excluding 0 and 1, excluding 0 and 1. We have given if x lies in the open interval, 0 is less than x is less than 1. That is the magical interval to me. Means you can or take all values 0.1, whatever it is, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. This is my magical interval where if you multiply, if you keep on multiplying, the quantity diminishes. Look, x square, take any value from here, I am taking 0.3. 0.3 square, it will become 0.09. Look at this. Instead of increasing, the quantity has decreased. That is the magic of this interval. Take x only, that is 0.3, good. If you find under root of x, as mentioned here, 0.3, one can calculate it is 0.466 and so on. Now look, this is our x square, x and root x. Normally, it is descending order for us. Order for us. X square x, then x raised 1 over 2. X square x, x raised 1 over 2. But in that interval, for that interval, it is increasing. It is increasing order. It is ascending order. Because x square is less than x and x is less than root x in that case. It is our ascending order. X square is less than x and x is less than root x. This is normally it is descending order. But if that is the case, value of x lies between 0 and 1, open interval, excluding 0 and 1. Excluding 0 and 1, that's the open interval between 0 and 1. Excluding 0 as well as 1. That is the magical interval where a quantity normally increases, but in that case decreases. This is normally decreasing as a descending order. Normally it is descending, but for this it is ascending order. For this it is ascending order. Means x square less than x is less than root x. So this is our magic interval. B. X square is less than x is less than root x. Normally it is a descending sequence, descending order normally. But if value of x lies between 0 and 1, this magic, any value 0.11, 0.2 something, 0.3 something, 0.4, 0.5, up to 0.9, whatever the case is, so on. It is our increasing order because x square is less than x and x is less than root x. That is ample proof for you. You can take any values from 0.1 to 0. Between 0 and 1, whatever you want to take. This is your increasing order. However, normally this is our decreasing order. For the rest of the real numbers. In case of between 0 and 1, it is our ascending order. Because x square is less than x is less than root x. I think I have made my point. Moving towards final question. If P and Q are primes greater than 2, then which of the following must be true? True. P and Q are primes, but P is greater than 2 and Q is greater than 2. Let me tell you something about P, about 2. 2 is the only even prime. 2 is the only even prime. 2 is the only even prime. The rest primes are odd. The rest primes are odd. 2 is the only prime. 2 is the only prime. 2 is the only even prime. Sorry. Let me stress this, emphasize this. 2 is the only even prime. 2 is only even prime. 2 is only even prime. The rest primes are all odd. The rest primes are all odd. Here we have been restricted that P and Q are primes and greater than 2. P and Q are primes and greater than 2 means neither P nor Q are 2. They are all odd prime numbers. Odd prime numbers. So what we have to do? Number one, check P plus Q is even. P plus Q is even. As we have restricted, we have bound that P and Q are greater than 2. Greater than 2. Greater than 2 means P is odd prime as well as Q is odd prime. That's the key in that case. This is odd. This is also odd. Odd plus odd result is even. Result is even. So number one option is valid. P plus Q is even. P plus Q is even. Good. We have done so. P and Q are primes and they are primes greater than 2. Greater than 2. 2 is the only even prime. 2 is the only even prime. 2 is only even prime. We have curtailed not to take P and Q2. Means they are both odd primes. Odd primes. I have mentioned here. P is odd prime. Q is odd prime. P is odd. Q is odd. Odd plus odd. Result is even. Yes, it's valid. What about second? That is P times Q is odd. P times Q is odd. As P is odd, Q is odd. Odd times odd. Odd times odd. Result is odd, definitely. So it is also valid. It is also true. Second proposition that is given to us, it is also true. What about third one? A tiny tricky one, but it's really easy for you. Let me pave the way for your understanding. P square minus Q square, what is mentioned? It's even. Is even. Let's prove. Don't bother yourself. Don't take trouble. Just factorize. P plus Q. P minus Q. Bingo. Here we go. P is odd. Q is odd. Odd plus odd. Result is odd. And P and Q are odd. Odd minus odd. The result is odd. We done. One can reconcile the fact by taking a number. 3 and 5. 3 plus 5. It's 8. That is 3 minus 5. Result is 2. So it is even. Odd plus odd. Result is even. Odd minus odd. Result is even. So this is our even. This is also even. We are familiar. Even times even result is even. Even times even result is even. So P square minus Q square is even. Means all the three propositions given to us are valid. P plus Q is prime. Sorry, P plus Q is even. Good. We have done so. Yes, it is even. P times Q is odd. Yes, it is odd. P square minus Q square is even. Yes, it is even. Provided that P and Q are odd primes. Odd primes because 2 is the only prime and we have been forbidden not to take 2. Value of P and Q is greater than 2. Value of P and Q is greater than 2. Greater than 2 means they are odd primes. They are odd primes. They are odd primes. Simply they are odd. Simply they are odd and you can manage the shoe. It's my tiny effort you guys explain to you some mathematics. It's all by itself. Next.